Welcome to the Rich Report, a podcast with news and information on high-performance computing. Today, my guest is from Adaptive Computing. We have the VP of Marketing, Chad Harrington. So, Chad, welcome to the show today.
Thanks, Rich.
Well, Chad, we've talked with Adaptive before, but it's been a while. So, why don't we take this opportunity to catch up on what's going on with Moab?
Yeah, we're excited. We're releasing our Moab HPC Suite version 7.0, and the company just turned 10 years old recently, so we're pretty excited about this release, and would love to chat a little bit more about Moab and what's in this upcoming release. So, just for the agenda for the brief podcast here, we'll give a quick overview of Moab so that everyone's familiar with what we do and what Moab's all about. We'll talk about 7.0, and then if you have a couple questions at the end, we'd be happy to chat about them. So to launch in, Moab is a workload manager, and we manage a number of the world's most capable computing systems. So we're on 40% of the top 10, 33% of the top 100 measured by cores, as well as a large number of leading enterprises. So our focus as a company really has been on making sure that we can scale to the needs of the very large, very complex, very high-end environments, because as you know in HPC, what's high-end today is middle-of-the-road tomorrow. So by always making sure that we're on the cutting edge, we're able to service the vast majority of HPC users from the highest down to the mid-tier organizations that also use us. So our focus is on being very capable, powerful, and scalable. And that's something that we've done now for, as I mentioned, a little over 10 years, and we've really enjoyed it. Moab is a workload manager, and we like to think of ourselves as kind of a brain, an intelligent brain that sits on top of your HPC cluster and decides where things should run and when. The benefits of that are really productivity, uptime, enforcing SLAs, and then, of course, being able to do things like grid and cloud that involve multiple sites and dynamic provisioning and reprovisioning of resources. So that's really what Moab does. It manages your workload. It saves you money by making sure your equipment is utilized as much as possible. We keep utilizations as high as possible. And we also make sure that you don't have as many failures and that you're able to meet your SLAs. In general, our customers purchase Moab because it's the best solution for managing these sorts of things at a really high scale. It's been a great privilege for us to be involved in some of the exciting advances that have been made in high-performance computing and help our customers to achieve the great things they can do in science and engineering and other fields using HPC and our products. So that's a little bit about Moab as the workload manager that we are. We now have a 7.0 release, and this is available as of Tuesday, March 13th. So we're excited about that release, and we've implemented a number of new things that have helped our customers to achieve their goals. Specifically, we've, and I'll talk about these at a high level, and then we'll dig into them each a little bit in turn, but we've enhanced and integrated the Torque Resource Manager into the Moab HPC Suite. Moab, as I described before, is a workload manager. It's kind of the brain that runs on one or two head nodes of a cluster. Torque is a resource manager that actually runs on every node. It's an open source project that we are the stewards of, and Torque is the code that starts and stops jobs on each node. So if you have a 10,000 node cluster, you'll have Torque running on each of those 10,000 nodes. They'll be communicating with Moab. Moab will be giving them the instructions. So we kind of think of Moab maybe as the brain and Torque as the arms and legs of the system that actually get the workload to execute. So Torque is part of the suite. If you buy Moab, you get Torque included and bundled with it. We also can work with other resource managers that other people may have, including some of our competitors' resource managers, as well as open source resource managers that are available. So the Torque 4.0 release, which is part of the Moab HPC Suite, was all about scalability and reliability, really taking it up to the next level. We made a number of infrastructure improvements that allow us to be able to deal with millions of jobs, hundreds of thousands of nodes, and tens of thousands of users. And we have customers that are pushing the envelope on each of those. There aren't any HPC clusters that we know of that have hundreds of thousands of nodes yet, but we're ready for that. We certainly have a number that have tens of thousands of nodes, and Torque is scaled up and ready for those enhancements. Next up is Moab Web Services, which is our new integration layer. We provide the ability to integrate with a lot of third-party partner and even customer-driven code that integrates with Moab. In the past, that's been done through separate interfaces. Now it's been rationalized into a single HTTP-based web services framework. We'll talk a little more about that. In the world of power and scalability, it's also important to not lose sight of usability, and especially as we push into more and more commercial enterprises and other organizations who just want to get their work done and don't really want to be system administrators. We've updated the self-service portal and admin dashboards to make them much easier to use for the different personas that will be using them. And that's really helped our usability. Another trend that we've noticed in our customer base is stronger desire for accounting and budgeting and chargeback, showback type activities. And so we've enhanced our Moab Accounting Manager to be able to handle that and to be able to be more flexible in its configuration. Job auto cancellation policies are kind of an interesting and unique feature that we've added at our customers' request that free up resources when a solution to a problem has already been found, and we'll talk a little more about that. And then lastly, we've expanded our support for different databases so that the environments that we run in can use the database that they're most comfortable with. So that's the high-level overview. There's a lot in this release. We've been working on it for quite a while and are very pleased with it and are excited to be bringing it out to the market. So let's talk about each of these individually. Torque 4.0 is all about scalability and reliability. As most of your listeners would know, Rich, communicating sequentially can be really slow, especially when you have lots and lots of nodes. Prior to Torque 4.0, Torque, the master node of Torque would have to talk to each of the perhaps thousands of nodes in order to start a job on each of those nodes. Now we use what we call a job radix, and that radix is sort of the fan-out function of a tree. Rather than having the Torque head node talk to each node individually, it talks to three. If the radix is 3, it will talk to 3 nodes. Those 3 nodes will each talk to 3 more nodes. Those nodes will each talk to 3 more nodes, and then that grows exponentially. And it becomes a tree instead of a linear sequence of communications. That literally can cut the job start time down by a factor of 1,000 on a very large system. So by being smart about this and using smarter communication patterns, we can get jobs started a lot faster on very, very large systems. We've also done a related thing when it comes to communications for things like status updates. Instead of each node contacting the Torque master and saying, this is my job status, they work through a distributed hierarchy. They contact a local master, and then that local master feeds the information up the chain to the Torque head node. So in a similar fashion, we're using trees instead of linear communications to get things done faster. We also made the communications engine multi-threaded. In the past, Torque would sequentially talk to each of these nodes in order. Now we do that in a multi-threaded parallel fashion. And we've moved everything to TCP-based communications, which are more reliable. So most of these overhauls have to do with the communications infrastructure because, as you know, in large systems, that's really what ends up being taxed. Those communication channels really can have a hard time keeping up if you have large numbers of nodes or large numbers of jobs. But with these enhancements, we've been able to push Torque well beyond where our customers are now and well into the future. So we're excited about that, continuing our leadership in scalability and reliability. Next up is Moab Web Services. As I kind of alluded to before, we integrate with a lot of things. We integrate with portals, scripts, resource managers, storage, all sorts of different things, and we have different interfaces for those. And our APIs, we've had APIs for Perl and for C and for Java, and we've kind of had to maintain those separately, and customers have had to integrate with them in different ways. Now we've standardized all of those into a single HTTP-based RESTful web services API. And now any language or any component that can speak HTTP, which is pretty much anything these days, can integrate with Moab and can take advantage of the services and the workload management that it offers, as well as feed information to Moab for decision making. So that's really powerful. It makes it much easier for our partners, our customers, and even ourselves to integrate with Moab. For example, our Moab Viewpoint portal integrates with the workload manager using that same web services API. We also have the notion of plugins, which is the idea that code, third-party code, can run inside Moab and access some of its internal state. And that's useful for things like security and accounting, other things that require a more intimate relationship with the workload manager. And so we've created that framework as well. Between these two things, it allows us to integrate very easily with the complex environments that we run in, as well as with the many partners that we have. HPC is rarely a single vendor proposition these days. It's usually a collection of different components, and we want to make sure that we play as nicely as possible with those other components. On the usability side, this is an important area to us. Powerful systems that aren't easily used aren't nearly as useful. So we want as many people as possible to be able to use an HPC system. We want to expand the universe of potential users. So to do that, we've worked a lot on our usability and our interfaces and how people can get their jobs done. First off, we'll think just a little bit about the administrator persona, someone whose job it is to manage this HPC cluster. We've really enhanced our tools here so that there are a lot of different views available, and especially we have really simple filtering so that you can say, I just want to see nodes that are over a certain load factor, or I want to see jobs that Rich started, or I want to see jobs that are in a particular state, so that they can quickly find the areas that need their attention. And as you think about moving toward the future, and we're in petascale now, but especially as we get into exascale, you can't deal with 10,000 nodes. It would just take a long time to scroll through a list that long. So really, we need to make it very easy for an administrator to figure out which nodes they need to care about. And that's where these powerful filtering functions come in. So they can focus in on the subset that need their attention at that moment, and they can get their job done. So we talked about administrators. There's also another class of people who interact with the system who are the users. And this might be a computational chemist, or it might be an oil researcher who's looking for oil exploration in an oil and gas company, or it might be a mechanical engineer who has designed a new windshield wiper or an airplane wing. And they don't want to be system administrators. They don't really want to worry about keeping nodes up and running and installing software. They just want to execute their workload. So we've made very simple job submission forms that make it very easy for the users to submit their job, to specify what resources that it needs, and hit go, so that they can submit jobs pretty much anytime and anywhere. And it doesn't require a lot of training. They don't have to know a lot about Moab. They don't have to know a lot about HPC, for that matter, at least in terms of the system administration workload management side of it. They can just write their codes and upload them and make their job start. So it's really simple. It also allows them very efficiently and easily to track the status of their jobs as they go along. And that's what most of the user community wants. They just want to get their job done. They don't really want to have to dig into details that aren't particularly relevant to their job. So we'll continue to enhance the usability right along with enhancing our scalability, and we think between those two axes, we really have a great product for our users. The accounting manager, Moab Accounting Manager, provides chargeback and showback capabilities. And this is something that we've seen an increasing demand for among the customer base. Perhaps it's because budgets might be a little tighter now. Perhaps it's just people trying to be more accountable about how they spend the shared resources. But in an HPC environment, you typically have a large cluster that's used by many users. And you want to make sure that time and resources are allocated fairly based on the organization's particular policies and design. So we allow, and I'll kind of just walk you through how this works here, but we allow an organization to set up almost an arbitrary organizational hierarchy. You can say engineering has two different groups. Here on this pie chart, we see we have an engineering A and an engineering B. Those might be a test and a dev group or other sorts of things. And then there are other departments. And you can set up a budget for groups that can be set by users, can be set by groups, can be set by particular accounts. And we say this is how the pie is going to be sliced up. Now when a job request comes in, as you can see here at the top, Moab checks the budget and says, okay, this is the job for finance. It's a simulation of markets or pricing analysis or some such job. And it checks the budget and say, okay, is there budget remaining? And if so, it can allocate and schedule that job, and then it can also track the usage and determine the charges that are related to that job, and then provide reporting for chargeback and showback at the end of that usage period. So it's a very flexible system. It has a lot of different policies that can be applied in order to apply different sorts of hard limits on spending, as well as soft limits where some people don't want to do charging and hard limits. They want to just show how resources are used. So instead of, let's say, for example, that the finance department has used up their budget for this billing period, in a hard limit environment, you could say, oh, sorry, can't run any jobs. In a showback or soft limit type environment, then the system could just say, okay, as long as there's capacity on the cluster, I will run the job, and I'll just report after the fact that that was an overage. And then the organization can decide how they want to deal with that. So different organizations have different policies, different hierarchies, and we've expanded the Moab Accounting Manager to take a lot of these different things into account. So it's very flexible, very configurable, and can be matched to a lot of different needs that our customers have. This is kind of an interesting feature, the auto cancellation policies. A number of types of workloads in HPC are a search for a particular solution. Maybe you're doing image matching to try and find a particular photograph amid a bunch of different databases. Or maybe you're looking for a particular solution to a mathematical simulation. But a number of different types of workloads have a single solution, or perhaps even a good enough solution. But to get that solution, the researcher or the engineer or the scientist will spin up a number of jobs in parallel, maybe even 1,000 jobs with different inputs, different parameters, different configurations. And in the naive workload management world, all those jobs would run to completion. And then the researcher would say, okay, did I find a solution? Now, the auto cancellation policies reduce resource waste by instead saying as soon as a solution is found, that particular job will exit with a particular success code, which is all the information that Moab needs, and then it will free up the other resources by killing all the other outstanding jobs, because once the solution's found, the other jobs don't need to run anymore. And that can save a significant amount of resources. Sometimes HPC jobs can run for days. So being able to exit early on all those other jobs makes a huge benefit in terms of utilization of the machine, reduces resource waste, etc. Now, if a researcher tried to do this by himself or herself, they would have to know the state of all the other jobs. And they would have to track, okay, there are 1,000 jobs. If I find a solution, I should go out and kill these other jobs. It would be very difficult. But because of where Moab sits on top of the cluster and getting this overall view, it can say, okay, these jobs are linked together in a job array, and if any one of them finds a solution, I should kill the others. It's something that can be implemented very easily with a policy in Moab, but would be very difficult to do manually. And that's really the power of Moab. So as you can see in the little animation here, you can submit an array of jobs with different parameters or different input files. And then you can use those files. Of course, we'll check policy and place them optimally. But once a solution is found, we'll automatically cancel all the sub-jobs that were linked to that job. So it's a very powerful mechanism that our customers helped us find that we needed to add, and we were able to add quite easily because of the power of our policy engine. The last feature that we'll talk about here today is just additional database support. Moab stores its metrics in terms of workloads and users and other sorts of status of the system in a database, and typically we've used a MySQL database to do that. Our customers actually reach into that database and do their own reporting and their own metrics and their own analysis from time to time. And some of our customers are more comfortable with databases other than MySQL for their own reasons. They've decided that they want to use Oracle or they want to use Postgres. And so we've just opened up that capability to be able to support multiple databases for the Moab Workload Manager. And that's something that allows the organizations to use whatever is their standard for doing databases. So we're excited about this release. It's an exciting one for the company. We've got a number of enhancements in here, all of which bring real value to our customers and continue to drive down those two axes of scalability and usability. And it's something that we're excited to talk about. Do you have any questions for us today, Rich?
Oh, I sure do. Thanks for that, Chad. We're kind of in the days now where a 2 petaflop machine with maybe 50,000 cores is run of the mill, right? There's probably 10 of them I could think of that are either running or in the works. How important is something like Moab and these new capabilities to these what we call hyperscale machines, right? Because we've got 10 petaflop machines coming out in 2012. So how important is Moab to that?
We, of course, believe it's crucial, and not only do we believe it's crucial, but our customers do as well. And as you saw from one of our early slides, we're on a large number of these very large-scale machines. If you don't use Moab, then your life is a lot harder. We'll put it that way. And the reason it's harder is because at scale, humans, our brains just don't work at scale. And you can make a lot of the decisions that Moab is making on a small scale. You can think about job ordering, and you can think about reservations for maintenance, and you can think about the accounting issues, all sort of on a small scale. But as you get to these larger and larger machines, it's just not humanly possible to keep track of all the things that you would want to keep track of. And although there are certainly other workload managers out there, Moab is far and away the most intelligent and the most powerful in terms of our ability to codify organizational policies and organizations and then automatically make decisions based on that. There's very little manual work involved in running Moab because once you've set up the policies and the rules, it's a rules-driven, policy-driven intelligence engine, and it can make a lot of decisions for you. Whereas with other workload managers, or worst case, if you just used a simple first in, first out queue, you end up making a lot of decisions yourself about who can run when, which machines can be used when, which workload runs where. Those sorts of things on small systems are quite easy, but the larger they get, the more users there are, the more jobs there are. It can have very complex decisions to be made, especially when you think about things like maintaining service levels and making sure that the right things can run at the right time. All of those are exacerbated by scale.
So, Chad, Adaptive's gone through a lot of change in the last couple of years, right? You changed the company name, and you got a big infusion of venture money. Is Adaptive able to accelerate the releases and the innovation that's coming out of the company? Have you been able to hire and do things faster?
We certainly have, and as you mentioned, Intel Capital and a number of other top-tier investors invested in Adaptive because they saw the unique technology that we had, and they saw the great market potential ahead of us. And we're very proud to partner with a number of these top venture capital firms who have been able to sort of fuel this growth that Adaptive has had. And we've had just great growth over the last couple of years as we've grown out our solutions. It has allowed us to hire more staff, to improve processes and scalability in a lot of different ways. And it's a very exciting time for the company. We are in high growth mode, and we're able to deliver more to our customers with better quality and faster turnaround time. So it's been a great ride for us.
Well, terrific. Well, kind of a wrap-up question here, Chad. We're heading to your neck of the woods for SC12 this year, right? That will be coming to
We
Salt Lake
are.
City. Yes. Yeah. Do you guys got any special plans you can tell us about at this time?
We are heavily involved, as you can imagine. We're part of the hosting committee. Um, we're excited to have everyone here in the heart of the Rockies and enjoy SC11 or SC12. I'm sorry. It's an exciting thing for us to highlight our state of Utah, and we've been in the HPC business for a long time. It's gratifying for us to be able to host a supercomputing show. And while we can't announce official plans yet, we've got a lot planned, and we're going to make it a super special SC12.
Well, that sounds terrific. Well, Chad Harrington, I want to thank you for coming on the show today.
Thank you, Rich.
Hey, it's been my pleasure. Okay, folks, that's it for the Rich Report. Stay tuned for more news and information on high-performance computing.